Okay, great. Now, here's my question to you. I am challenging you to take the time you have now to invent something brand new. And if you can't invent something brand new, I want you to learn more about something you're interested in. So, what might that be? Has anybody been thinking about an invention? Who is going to be the next Isaac Newton, who literally went home for a year, was in his room for a year, and came out and changed the world? Reed, what do you have?
Mm. Well, I was actually thinking about just a wireless extension cord, but I remember that's impossible. Wireless
Wait,
extension
wait a
cord.
minute. Reed, I am not so sure that is not possible. So we know that there is wireless charging, right? You can charge your computer wirelessly, all right? So why don't you think of a way that you could use, and you might have to use some circuits, and you might have to get some batteries and wires and safely work with your parents to do this, but maybe you could come up with something
I
that
just
would
think it
create.
wouldn't work to get electricity from one point to another. And if it did work, it would take like a long time to actually get like 10%.
Well, you know what? I can't wait for you to try. And if you don't try, and if you don't fail, you will never invent. So please give it a shot. Bogdan, you're up next. And everybody should be thinking. I want everybody to give their ideas, their comments on this one. Go ahead,
I,
Bogdan.
I was just gonna say that if they did do if they invented like wireless charging, then they could probably invent someone could probably invent a wireless extension cord.
Yeah, I think it's very possible, Reed. So
Yeah.
so Bogdan is excited about it. And what about you, Walker? What about you, Isabella? Rennie, Brody, Cole? What can you invent? Milo, I still don't see you, Milo. I see the top of your head. But don't think that you have to actually sit up straight. All you have to do is angle your computer down so you can be seen in the middle of the screen. Rennie, do you have any ideas?
No, not
Anything you're
yet.
thinking about? Okay.
No,
How about you, Cole?
no.
Anything? And how about you, Milo?
Maybe I'm thinking maybe like I just remember I have a lot of Skittles at my house, so maybe like a Skittle shooter or something.
Okay, wait a minute. Milo, I have a deal for you. If you invent a skill shooter and you become really good, I will let you shoot the Skittle shooter into my mouth because I love Skittles. But you have to invent it so the velocity of the shot is not too hard because if you miss my mouth, you might hit me in the eye. So it's got to be something that's kind of, it shoots, but it shoots softly. So you have to think about all the ramifications. Excellent idea. Isabella?
Um, well, I don't really know, but all I know is that like kind of like for this, like when we do it, are we allowed to like do it like with like other like members of your family? Because I feel like I've also like one time there was like this idea that I had, and and I did it, and I like just kind of did it with my grandparent. I think we could with my grandpa, and I think we could like do it online. So like if we do it, are we allowed to like do it with other people?
Okay, let me explain something right now. Isabella, that might be the best invention of all. Is that when we work together in teams, it has been proven, Isabella, that people get more accomplished. So Sir Isaac Newton is one of the most amazing people because he did it all himself. Now, I'm going to say that, Isabella, and then I'm going to say something the opposite. When he came back to Cambridge, remember he was 22 years old, he spent the next decades of his life working with the other scientists together, like you want to work with your grandparents, and he invented even more. So I want you to think about, first of all, I think your grandparents will be very excited, but I want you to come up with a list of like 5 ideas that you have your grandparents come up with 5, and then together figure out what you want to create. So does anybody else want to add Any ideas, Walker? Have you been thinking of anything, Brody and Cole? Go for it, Brody.
Can we like draw something?
Dude, of course. Are you kidding? How do you think inventions are started? Brody, you have to create a drawing. Usually people create two-dimensional drawings, then they create three-dimensional shapes. Back in the old days, they used to make them out of clay or even dirt, and sometimes they would carve them out of marble. And then you start putting together a prototype to see what works. So Brody, drawing a picture is the best way to start an invention. And yes, Bogdan.
So because it's my dad's birthday today, I thought I could make some kind of like birthday pop-up thing.
Wow, it's a great idea. And I want to share the favorite idea that I got this week, okay, from a student. So I have a student who is a second grader, and he wants to create a cell phone case that is a bouncy ball. So you know how people are always dropping their cell phone cases or cell phones? Well, you know how the case protects the cell phone. But he said, what if the cell phone fell and then it bounced right back up to your hand? And I was like, oh my God, that is a cool idea. So I hope I didn't give anything away. I hope that he's the first one to come up with it. But what a great invention. What a great invention. So now, here is an invention I would like to create. I would like to find a pair of skis that would allow me to ski safely down this mountain.
Oh, jeez.
What do you guys think?
I agree.
Would it ever be advisable to ski down a vertical slope?
No.
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 No. In fact, it is a really bad idea. However, do you guys see our little friend right here?
No.
Not a terrible idea.
Yeah, he is actually
He's
doing
gonna
it.
die.
Well,
No, he won't.
actually he did not.
He
And the
won't.
reason that he did not, actually, I apologize for that. I don't know why that happened. The reason why he did not die is because what? Tell me about this mountain. Is it a vertical drop?
No.
No.
Not exactly.
No.
It's at an angle.
Ah, so the angle you see is very, very extreme. It's very
120?
possible that that angle is about a 70-degree angle.
Huh?
Okay, and Walker, yes, buddy.
Yeah, because if it has at least a slight angle, then if it gets to the bottom and the angle gets less and less extreme, then it'll just start going slower and slower as
Ah,
it goes further.
so Walker, what would you need to go slower and slower and slower? What physical property do
Friction.
you, friction. Yes. And tell me about the friction, guys, in a vertical drop. What is the friction? Is there any friction?
Yes.
Yes.
No.
Wait. Who said yes? I want to hear about that, Bogdan. Tell
'Cause,
me
like-
about the friction in a vertical drop. What kind of friction could there be?
If you're actually like touching the slope, then there is at least some friction.
Maybe. Does anybody have any other ideas? Reed, what do you think? What kind of friction
No.
is there?
Because to have friction, it has to go. I'm just throwing this out, but it has to go at a steady pace. It has to stay straight for a small period of time. And with a vertical drop, that's almost impossible.
So it's interesting, guys. Did somebody else, Brody, did you have some ideas on this one? Or Walker did? I'm sorry, Walker had some ideas, and then I'm going to go call him Brody.
There's actually like air friction and there's a bit of friction on your skis if your skis are touching the slope.
Guys, there is a lot of air friction. So air creates a lot of friction, which ultimately creates something called terminal velocity. that we can talk about at another time. So what I want you guys to do right now is tell me if a vertical slope is a bad idea, what number do you think is associated with a vertical slope?
0.
90 right angle.
Well, it's a really great answer, 90 as a right angle. Now, 0 is interesting. Let me introduce you to a 0 slope. A 0 slope is on a day when Mr. Kramer is very tired and I want to go cross-country skiing because I find that very relaxing. Not really my favorite type of skiing, but this, everybody, is a horizontal slope of 0. So if this is a slope of 0, then what do you think the number would be associated with a vertical drop?
Oh, 180.
Well, it's 180. I hear you, but it's not in degrees because the 0 slope is not 0 degrees. I want you to think about a number, and it's not the opposite of 0 because 0 has no opposite. If you remember at the end of every class, we count from a negative number up to 0, and I say never say negative 0. So there's no opposite of 0, but what number do you think it is?
Negative 90? Negative 180?
It doesn't have to do with the degrees, but I love the fact that you're thinking about it. And the number is, if nobody else has any ideas, I'm going to throw it out here and I'm going to draw a picture. You guys ready? It's one of my favorite symbols of all time.
Infinity.
So a slope that is vertical is an infinite slope. And infinity is called undefined. So everybody draw the infinity symbol, and right below it, draw what's called the undefined symbol. Undefined. And the reason it's called undefined is because you can't define infinity. Isabella, I don't see you. So if you could, yeah, there we go. Excellent, excellent. Okay, great. Now, let me tell you how we get there. There's something in mathematics. I just want to make sure, does everybody still see my screen?
Yes.
Okay, great. There's something in mathematics called slope, as you know, and slope is found by looking at the change, the vertical change, which is called the rise, divided by the horizontal change, which is called the run. Everybody say it. Rise divided by run.
Rise
divided by
1.
Now, I want you guys to tell me, what is the rise of a vertical line from, like, let's say this point right here to that point right there? How many feet do you think that is? Just give me any guess. Anybody can say it.
I think it's 40 yards.
Okay, let's call it 40.
I think it's
Now,
Yeah.
what is the distance of the run? The horizontal movement? And Milo, I can't see you, so if you can angle your computer down all the way so I can see you. Okay, guys, does anybody have any idea how far we're moving to the left or right?
15 yards?
70.
Guys, go from point to point. Is there any movement from left to right?
Yes.
This
No.
would be movement to the left. This would be movement to the right. Is
No.
there any movement?
No.
So therefore, what number would be the run?
0.
And everybody right now tell me, what happens when you divide 40 by 0? What do you get?
0.
Ah, everybody now pull out their calculators, whether it's on your computer, your iPhone, your iPad, or if you have an actual calculator, and everybody hit 40 divided by 0. And then, but don't tell me what you get. Everybody do it. 40 divided by 0.
Bring me into calculator.
Oh, Reed, I like that one.
Uh-huh.
That's a very cool calculator. Now, Vrenny, we're going to start with you, Vrenny. What do you get when you divide
Bring me to
40 by 0?
0.
Your calculator says 0.
Well, I didn't do a calculator because I don't have a calculator.
Ah, okay. Do you have a computer in front of you?
Yes,
Do you know that there's a calculator on your computer? Do you know how to find it?
I think.
You know what? Don't look for it just yet because you might lose the screen. Brody, do you have a calculator?
I just used the computer's calculator.
And what did it say?
Infinity?
It really says infinity?
Yes.
Awesome. What about you, Isabella?
I don't have a calculator.
Okay, what about you, Milo?
I don't have a calculator.
Okay, what about you, Cole?
I don't have a calculator.
No cell phone handy?
No.
Okay. How about you, Walker?
I can get
It says
one.
undefined.
I have to go online.
And does your calculator say undefined?
Calculator.
Yes.
It does. Wow. So guys, listen to this. Walker's actually says undefined. It actually says undefined. Bogdan, what does yours say?
Same. It says undefined.
Mine says error.
Ah, I was waiting for that. Most calculators actually say error. Now, my invention, guys, and you might laugh at me right now, so I'm okay with that, is to invent a calculator that if you ever try to divide by 0, the calculator will start to like smoke and start to fizzle and it will self-destruct.
Why would someone make that?
Because think about it. Can you ever divide by 0?
Yes, it makes
No.
undefined.
Well, you cannot. The point is you cannot divide by 0 because the answer would be infinitely high. So therefore, I never want you to forget that a vertical line has a slope of infinity or undefined or error. Okay, now my favorite slope on my ski adventures is my favorite slope a slope of 0? Is it a negative slope from left to right, negative slope going down, or is it a positive slope from left to right? What do you think is Mr. Kramer's favorite place to go skiing? And I want to hear from you guys. What do you think? You think it's negative?
Yeah.
Negative.
And guess what? Absolutely. Walker, what do you think?
Negative.
Definitely. Now, why do you think I am not a fan of positive slope? Why am I not a fan? Go ahead, Brenny.
Because you have to like hike up because you can't ski up.
Yeah, so guys, I use a chairlift, okay? I let the chairlift do the work. I do not like skiing up a mountain. Some people do, trust me, some people do. Me, I like skiing downhill. So I'm a big believer in negative slope. I also do not like 0 slope, but I know it's very relaxing. But I will promise you, I will never, ever be on a vertical slope. Never, ever. Now, let's take a little journey here, okay? I want to talk about the slopes on some of these lines. Now, I want you guys to give me a color of a negative slope of -3/2. Who can give me the color of the line that has a slope of -3/2? Now remember, the slope will always ask you to do what's called a rise over run, or rise divided by run, and the rise is always up. The rise is always positive. The run can be negative if it goes to the left, or positive if it goes to the right. So on 3, guys, what color first. Don't say the number. What color? On three. 1, 2, 3.
Red.
Pink.
Red.
Oh, red.
Pink.
Right.
What else do you think?
Green. The dirt.
Oh, green?
Swampy. No, the one.
Light green.
Oh. Let's take a journey, please, on green. So the journey on green, I
1.5.
see a rise of 3, yes? And a run of what?
2.
Okay, so what's the slope of the green line?
1.5.
Give it to me as an improper fraction, but you are correct.
3 over 2.
Yep, that slope is a positive. Remember I told you, positive from left to right. It is a positive 3/2. Now, let's go with red. The red slope is what, guys?
1/2.
1/1.
Ooh, who said 1/1? And who knows how to simplify 1/1? Say it.
1.
So the red line has a slope of 1 because it's a rise of 1 and a run of 1. Who can tell me about the pink slope? Now the pink slope has a rise of 3, just like the green did, but the run is negative. Negative what?
2.
2.
So it's a rise of 3 and a run of -2. What is the slope of the pink line?
3
Over negative.
3 over
3
negative
over
2.
-2.
Or you can just say it as -3/2. -3/2 is exactly right. Now, who can tell me the color of a slope of 1/5? I am looking for a slope of 1/5. A rise of 1 and a run to the right, which is 5. Who can tell me? Come on, I want to see some raised hands here. I want to see some raised hands here. Cole, go for it. What color?
Purple.
Does anybody agree with Cole?
Yes.
Yeah.
I agree with Cole.
Oh.
I agree with Cole. Who had a different idea? Because I'd love to explore that. Reed?
I thought it was blue, then I noticed it's 4, not 5.
Yeah, but the blue, Reed. Who can tell me, and Reed, you're going to answer this, but I want everybody thinking right now about the blue line. It is definitely 4, and it is definitely a run
-1
of
over 4.
1. But
-1 over 4.
-1/4. I'm going to show you a rise of 1
Oh,
and a run
-4
of
over
4.
4 over -1.
Why do you say -1? Are we not going to the right?
Oh, I thought it's the other way around. So it's
So-
1/4.
Actually, no. 1/4 would be a slope that looks like this because it's a rise of 1 and a run of 4. That's a 1/4 slope. Who can tell me the slope of the blue line? Hands up. Blue line, blue line. On 3. 1, 2, 3.
4 over 1.
Over 1.
Which is
4.
what, guys?
4.
Which
4.
is plain old 4. So you've got to look at that blue line. Reed, do you understand that? It's up 4 and over 1. Up 4 and over 1, which is exactly 4. Now, who knows the slope of the orange line? The slope of the orange line. Bogdan raised his hand. Hold on a second, Bogdan. Cole and Brody raised his hand. Brody, I'm going to go with you on this one.
1 over -5.
And you can say it as
Negative
-1/5.
5. Or -1/5.
Now, Isabella, can you tell me the slope of the olive line? And everybody should be thinking about it right now. The olive line right here. We've got a rise and a run.
2 over 2.
Well, 2 over 2 would be a rise of 2 and a run to the right of 2, which actually, isn't that the same as our red line over here?
Yeah. Oh,
Which
2,
is,
2 over negative 2.
oh, I love it. And now who's going to simplify that for me? Raise your hands to simplify it. On 3, 1, 2, 3.
-1.
-1.
And guess what? This has a slope, Isabella, of -1. You are exactly right. And now, where would you like to go with me on the green, the dark green? Where you want to go? And beyond.
0.
Oh, 0?
Oh, no.
No, it's
Undefined.
yeah.
Oh, that's
Ava.
right.
Undefined.
So Brody, remember, a 0 slope
Right.
is what you never want to downhill ski on. That is which line here, guys, has a slope of 0? What color?
Dark green.
Or green.
Nope. Nope. A slope of 0, guys. Come on.
Blue.
Nobody can find it. Milo, are you
black,
looking for
black.
it?
Oh,
Black.
black.
Guys,
Oh.
it is the horizontal line, the cross-country skiing. You're going nowhere, okay? Now, the vertical line has a slope that is, as Walker's calculator so adeptly said, undefined. Now, I'm going to show you, we're going to take a little journey, by the way, through all the different pictures that you guys are going to create this week and next week and the week after, all throughout the summer. I sent your parents a 42-page PDF that I asked them not to print. And I said, don't print it because it's too long. But what I want you to do is I want you to go through it and say, hey, I'd like to create a coordinate picture of Lisa or Bart Simpson, somebody from Sonic the Hedgehog, Batman, Superman, Mario, whatever you want to create, you can create. Now, let me show you what these look like, okay? So the first one I did is I actually did a coordinate thing of Mathlete, which I thought was a little fun. It doesn't look beautiful, but it was fun to create. And then I created one that was, well, here's Mario, okay? And he's made up of over 200 coordinate points. So a lot of work. This one is called Antoine Decoulette, and it's really beautiful if you want to create him. Let's see. This one here is a walrus, and it's a lot of fun to make. This one here is actually Sonic the Hedgehog, and it's beautiful. This one here is something called Rogue. So she's also from Sonic and a really cool character, and I like her. This one here is Miles. Miles Tails Prowler. Does anybody have a question about any of these yet? Go ahead, Reed.
Isn't it pronounced Roach? Like-
No, I don't know. Maybe
I
it
just
is.
watched the show once and one person kept pronouncing it Roach, so I didn't know if it's correct or wrong.
I would assume that you are correct.
Hmm.
I would assume that you are correct. This one is called Whammy, and I don't think he's the most interesting, but I really like the spikes on his back. So I think that that's kind of a neat one to create. The next one here is beautiful. This is called Princess Sally Acorn, and it's one of the prettiest ones that I've found. But the one that I like the most is Bart. I love doing Bart. Now, the only reason that I don't suggest doing this is because it's only in the first quadrant. So I had to give you first quadrant only graph paper, which is only positive numbers. So it's not as much fun as working with negative numbers, which I really enjoy. So what I want to ask you next is this question, because this one here is another one that's a lot of fun. So Lisa Simpson creates an image that looks like this. You guys see it? Now, if I asked you, what is the length, and I want you guys to write this down, what is the length of the segment from 7, -3 to 11, -3? And send me a chat with the answer. So it's 7, -3 to 11, -3. Send me a chat with the distance and also the slope of that line, please. You guys still see my screen?
Yeah.
Okay, because I just hit a button, a funny button. Okay, so did you all send me a chat? And Walker, what do you think it is?
40.
Oh, it's got a, what, can you say it though with using a couple sentences?
Oh, the distance is 4 and the slope is 0.
I totally agree. Now, does anybody, okay, no problem there. Some things sometimes happen. Now, I've got a very, very special one for you now. You ready? What is the distance from point 39 to point 712? So I want you to think about that. It is a non-vertical, non-horizontal distance. Very, very hard. Very, very hard to do unless you know a beautiful theorem. And I want to know if I have any raised hands, any ideas about it. Reed, how far do you think it is?
I think it's between 3 and 4.
No.
Well, let's see. Would you guys agree that
Like 5.
that the horizontal distance between them is 4
Mhm.
and that the vertical distance between them is actually what?
3.
Okay, so vertical distance 3, horizontal. Oh, by the way, I don't like the picture right now, so I'm going to change it. I'm going to blow this up to 200%.
Oh, wow.
Okay, so now when I make my vertical, it's actually easier when I make my horizontal. Now, who can tell me the slope of this line real quickly? Raise your hand if you could tell me the slope of this line. Remember, it's a rise divided by the run. A rise divided by the run. Vrenny, you got that? What's
Almost.
the rise over the run?
0. No, 1.
Oh, it's please don't call it out. And it's definitely not 1, but it's really close to 1. So again, Vrenny, you've got a rise divided by run. You've got a rise of 3 and a run of 4. Come on, Vrenny, you can do this.
-1?
Well, Vrenny, tell me the rise and put that number here.
3,
Tell me the run and we'll put that number here.
4.
Can you read that number?
Oh, 3/4?
It's 3/4.
Yeah.
So this is exactly 3/4. Now, who can tell me the length of point AB? So the length from A to B. Now, Reed said it was between 3 and 4. And I really like how you started that, Reed, but I want to hear from others. Walker, any ideas? Brody, go for it.
I think it might be somewhere between like 4 and 6, maybe.
Ah, now I want to show you how far 6 is. This is 6 right here. And if I kind of take that line almost like on a hinge, look at where I end up. So 6 seems to be a bit long for that. So, but I really like what you said. Isabella?
Maybe like 4 or 5.
4 or 5? What do you mean 4 or 5? Oh, 4 or 5?
Yeah.
Okay, now, do you think that this AB can be the same as BC?
No.
No.
Does it have to be longer or shorter? Milo, what do you think?
Longer.
Does AB have to be longer or shorter than CB?
Longer.
It has to be longer. So we know it can't be 4. Any other ideas? Go ahead, Bogdan.
I think it's probably about 5, but maybe probably a little bit around 5.
Okay, guys, guess what? I'm about to introduce you one of the oldest known mathematical theorems in the history of our great world. And that is called the Pythagorean theorem. So Pythagoras lived around 400 BC, maybe 480 BC, I'm not sure exactly.
I've read a book on this.
And Pythagoras was a teacher. Now, Mr. Kramer is no Pythagoras, okay? But Pythagoras had a school, and instead of them being called mathletes, they were called the Pythagoreans, okay? Now, I am really excited about Pythagoras because he said that if you have a triangle with a side of 4 and another side of 3, all you have to do, and watch this, guys, this is so much fun to explore, but hold on a second, I'm gonna throw this over here. If you look at this, what is the square of the 3? What's the square of 3? 3 times 3.
9.
9.
What's the square of the 4? 4 times 4.
16.
16.
What happens when you add the 2 squares together?
You get 25.
25.
And now, I don't know if you guys know this concept,
Oh.
but what is the square root of 25?
5.
5.
Well, guess what, guys? Isabella said it. I think a few other people said it. This segment has to be exactly 5. It can't be anything else. So let me give you a little journey on Sonic's head, okay? You have a distance, and I'm going to show you this as point AB. You guys see it?
Mm-hmm.
You guys see point AB?
Yep.
Yeah.
And how long is the leg BC?
1.
1.
1. How long is the leg AC?
4.
What's the square of 1?
1.
So you just said that 1 squared is 1. What is the square of 4?
2. 2.
The square of 4.
Oh, square.
16.
16.
If you said 16, you're correct. So 1 plus 16 equals what?
17.
17.
And what is the square root of 17?
There is none?
Oh,
There is.
Oh, wait, actually, no, there is.
it
Like
is one, but it's
4
between.
It's between 4 and 5.
4.
Ah.
Yeah, between 4 and 5.
Who just said between 4 and 5?
Bogdan.
Bogdan. That was awesome. Now, I want to share something with you, okay? If you have your calculator, I want you to put in your calculator right now the square root of 17. Now, if your parents are there, they can help you. If not, we're going to put in our calculator the square root of 17. And Bogdan said,
Say error.
wait, say again?
My guess is it'll say error
Oh, you know what, my friend?
because
It
that's
will-
half like the point today.
It's definitely not going to say error. In fact, my calculator says, Bogdan, what does yours say?
It says like 4.12310.
5, 6, 2.
You guys see that? Now, why do you think
Calculator.
the square root of 17 is closer to 4 than it is to 5? What is the square root of 16?
4.
Oh, by the way, somebody is having construction done in their house. Can they just hit mute for just a second? There's some machine that's going. It could be a drill or a vacuum. I'm
That's
not
probably
really sure what it is.
That's probably me.
Oh, okay. Yeah, if you hear it again, you can just mute it. Now, so we know the square root of 16 is 4. What is the square root of 25?
5.
5.
Okay. So when Bogdan said that the square root of 17 was between 4 and 5, was he correct?
Yes.
Well, many, many years ago, your friend, Mr. Kramer, came up with an algorithm. And this algorithm seems so simple, but I've never seen it on the internet. Like, it's not like a way to estimate square roots. You'll see the Babylonian method. You'll see a lot of other methods. It seemed really simple to me, but I want to share it with you. Are you ready? If you take the difference between 16 and 17, what do you get?
1.
1.
If you take the difference between 16 and 25, what do you get?
9.
9.
9.
So guess what? My estimate for the square root of 17 would be 4 1/9, which is equal to 4 point.
Oh.
Anybody know?
90.
1, 2, 3.
1 repeating. And by the way, so my number is an estimate. When you do an estimate, you make 2 little squigglies. Everybody make 2 little squigglies right now. This means estimate.
1.
And I love making little squigglies because I love making estimates.
I like making them because they're like.
Yeah, I think they're pretty cool too. So the actual square root of 17, though, guys, is 4.123, which means that my number had a delta, a difference. Everybody draw a triangle. That means difference in Greek, or change. Mine had a change of approximately 0.012 or 12 thousandths. Now, would you guys like to see this done again? And then
Yeah.
you're going to be able to do it yourself. Okay, here we go. You ready? We're going to start with a list of the first 100 square numbers. And it's going to be helpful. So let's take the square root of 24. The square root of 24, do you guys see it somewhere between 4 and 5?
Yeah. Yes.
Isn't it less than, isn't the square root of 24 greater than 16?
Yes.
Greater than the square root of 16?
Yes.
And isn't the square root of 4 less than the square root of 25? So it's between 4 and 5. What's the difference between 16 and 24, Milo?
16 and 24, 8.
And what's the difference between 16 and 25?
9.
And I am off by 1/100th. Now I want everybody right now to write down the square root of 29. And I want you to write the square that is smaller than 29 and the square that is greater than 29. And if you have any trouble, you can look at the chart above, which has the square below 29 and the square above 29. So how many of you got 25 and 36?
Me.
Okay, now I want you to write below the 25, what is the square root of 25? Go. Remember Walker told us before,
5 through 6.
the square root of 25 is
5.
5, and the square root of 36 is
6. 6.
and therefore the square root of 29 is between what two numbers?
5 and 6.
So it's 5 and a fraction. I want everybody, and Cole, I want you to write this down. I want you to write down 5 and then a fraction. And the numerator is going to be the difference between 25 and 29. And don't say it out loud yet. And the denominator is going to be the difference between 25 and 36. And that estimate will be unbelievably close to the actual square root of 29. So write it down. And if you want to send me a chat real quickly as to your answer. So Brenny, what we're doing, Brenny, is that we know that the square root of 29 is between 5 and 6 because it's between the square root of 25 and the square root of 36. So therefore, the numerator, Brenny, is going to be the difference between these two numbers, and the denominator is going to be the difference between 25 and 36. So on 3, folks. 1, 2, 3. What's the fraction?
4 7.
5
4
and
11.
4 elevenths.
And if you put 4 elevenths to your calculator, so you ready for this? Hold on. Put 5 and 4 elevenths. If you just do 4 elevenths, you'll have it. You will get, I believe, 5.36 repeating. Anybody do that?
Wait.
5.36 repeating. Okay? And when you put in the calculator the square root of 29, what do you get? Raise your hand, please.
It's not letting me do it. I'm literally using an online calculator,
Yep. And
and it's not letting me
the
do it.
square root of 29 on 3. 1, 2, 3. Anybody?
No, my calculate. I'm using an online.
Well, I'm asking anybody who does have the answer. So anybody who does have the answer. Bogdan, go for it.
I was gonna say, isn't it 4 7ths?
Well, let's go back, Bogdan, because you may be right. If I'm looking at the difference between 25 and 36,
Oh wait, no,
is that not 11?
no, yeah, it is 11. I was thinking of 29 and 36.
Ah, very good. Very good. So that was, you know what, Bogdan, that's the kind of question I want to hear from my mathletes. Now, who's got the answer, guys? Go. 5 point.
Hey Siri, what's 5 and 4 elevenths equal to in fractions? No, I said fractions.
Okay.
What did Siri say, my friend?
Oh, and I did fractions, not decimals.
Okay, you guys ready? You know what my difference is? My difference, my delta was 0.021, 21 thousandths off of the correct answer. So I want you guys to practice this. I want you to spend this week creating all of these pictures. That's the most fun you can have. But every time you create a line, I want you to go to that line and say, okay, I know that this line right here, you ready for this? That line right there has a slope that is what? Who can say it? On 3. 1, 2, 3, go.
1.
1 over
1.
negative
1
4.
over 4. 1
1 over
4.
negative 4.
Now, I only heard it correctly from Isabella. So the answer is a rise of 1 and a run of 4. So this has a slope of 1/4. Now, if you take the square of one side, 1, plus the square of the other side, 16, you will get the square of the biggest side, which is called the hypotenuse. And remember, we got the square root of 17. Now, who, before we close out, and we're out of time, but I want to know if anybody can tell me the length of that red segment that I just created. And while you think about it, I'm going to draw some squares that might be able to help you.
Is that correct?
And I saw somebody raise their hand, which is great. And you can test it on your calculator to see what it is as an estimate. How many of you
Oh, I know it.
got the square root of 9 plus 4? The square root of 9 plus 4, which is the square root of what?
13.
Oh.
That is absolutely correct. And if you know the algorithm, you say the square root of 13 is between the square root of what and the square root of what?
9 and
17.
Come on, Walker, unmute yourself, Walker. Between 9 and what?
9 and 16.
9 and 16, which must be between 3 and what?
4.
And it must be 3
That's
and a
3 points.
fraction. Who can tell me what our estimate is going to be? Our little
3.5.
squiggly. Come on, numerator.
4/7.
4 over 7. Guys, guess what? The segment we just did with Sonic is literally very, very close to 3 and 4/7. Amazing job. So I'm very, very proud of you. I worked with another group and we didn't even get to the square root algorithm because slope was much harder for them. You guys did a great job, and I'm really proud of you. Walker, you raised your hand, buddy. Question.
Oh, I did.
Oh, that's okay. That's okay. Now, we are going to actually count from one of my favorite numbers right now. Walker, you raised your hand again, buddy? Or is that just an accident? Oh, yeah. And also hit the unmute button right now, as well as Isabella and Brenny. Okay, here we go. We're going to count from, let's see, let's go from -85 by 17, since we've been talking about 17. Are you guys ready? Go. -85.
Negative 58.
Very good. Keep going.
Negative
Negative
41.
51.
Oh, beautiful.
Negative
Negative 34.
34.
Negative
Negative
17.
17.
But don't ever say negative what?
0.
2, 4, 6, 8. Who do we appreciate?
Yay. Humans.
Humans. Oh, and by the
Life.
way, give me the slope of mathletes. So that slope is what?
A lot.
Infinity.
Oh.
This slope is what? Negative or positive?
Negative.
Negative. This slope is what?
Positive.
Positive.
And this slope is what?
0.
Negative.
Infinity.
Uh,
And this slope is what?
0.
0.
0.
Yeah.
Guys, I will see you in 167 hours. Please send me by email a picture or scan of any pictures that you create. If you color them in, they'll be even more beautiful, but I will put them all on my website. Say goodbye to your friends. It's great to see you guys, and we'll see you soon.
Bye.
Bye, guys.